let's continue talking about probabilities, but now we're going to talk about what is considered compound events. Compound events, there's a couple of different things that we can look at when we talk about compound events. What we're going to first talk about are compound events where you are talking about two characteristics of the same object. So in other words, like a blue ball or a black cat. So you're talking about the ball, the fact that it's a ball, and the fact that it's blue. Or you're talking about the cat, it's an animal, but it's a cat instead of a dog, and that it's black. So you're looking at two characteristics of the same object. When we look at those, we look at something called a contingency table a lot of times. A contingency table is just a way to organize the data. And so I'm going to look at one that I've already set up. A contingency table looks at, again, two characteristics of the same items. So like in this case, we look at the make of cars, so Ford, Toyota, Kia, Honda, Chevy, and we also look at the types of them, whether they're SUVs, coupes, sedans, trucks, or hatchbacks. And what this table does is it goes through and counts up, okay, how many Ford vehicles are also SUVs? And then it puts that number here. How many Ford vehicles are also coupes? And it puts that here. And so this column is telling me how many total Ford vehicles there are. And this row is telling me out of the the 5 different makes here, how many SUVs there are. And so this number right here is this column added up, but it is also this row added up. Now it is not these added up and added again, so you're not doubling it, okay? This row should give you this number, and this column should give you this exact same number. This number right here is basically telling you, okay, how many vehicles total do we have? It's telling you the total number in this table. That is what this number down here is telling us, okay? That is what a contingency table is looking at. Now, we use the contingency table to look at different types of probabilities. We can look at basic probabilities. Say I want the probability that if I select any car, that it is a truck. So the probability that it's a truck. So I can come here to trucks. Okay, so there's 19 trucks. And there's a total of 152 vehicles. And so I can either do that division, or I can also see if that will simplify, which it actually does. It simplifies into 1/8, or you can use it as 0.125. So if I go here 1 out of 8 times, I might get a truck. Okay? Now, let's look at if I want the probability that the vehicle that I select is a coupe or it's a Toyota. So this or is going to be huge for us, okay? So or means that it can be either one of these. So I'm going to include all of my coupes, so all of this row here, because it can be any one of these, or it can be any one of these Toyotas. So if I look at my coupes, there's 13 coupes out of 152, and there's 45 Toyotas out of the 152. Okay, so I'm going to add those because I can have either one, right? Be careful. Notice these three right here were counted both times. They were counted in with the coupe and in with the Toyota. Whenever there's something that is not mutually exclusive, meaning you can be a coupe and a Toyota at the same time. Therefore, they're not mutually exclusive. There's an overlap here. If things are not mutually exclusive, you must subtract out that intersection. You need to subtract out the 3 out of 52. And the reason why is because you don't want to count these 3 again. So overall, 13 plus 45 minus 3 would actually give me 55 out of 152. And so I would have 55 out of 152, which doesn't simplify, but I could use a decimal of 0.362. Now I know in the contingency table it may be a little bit difficult to look at, so let's come over here. Now if you've ever played the game of Guess Who, which I know some of you have, this is a set of tiles from a Guess Who game, okay? And I want to look at this because I want to talk about these mutually exclusive and not mutually exclusive items. Now, what I was looking at just a moment ago with something being a Ford or a coupe or a Toyota would be similar to me saying I want a female or a soccer player. Okay? So that means I would go through and I would include all of my females. So that's going to include all of these. Let's see here. Becca, Michelle, Jill, Erica, Julie, Gianna. Okay. So I've included all of these. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 females. Now I need to go through and include all of my soccer. Well, here's 1, 2, 3, 4, 5. Okay, so I have 5 soccer. But what do you notice? Alyssa, Jill, and Tia were counted both times. Well, I can't count them both times. In other words, if I just went through here and counted female or soccer, I would just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But if I do the addition of all the females plus all the soccer players, I would get 17. But I've got to subtract out those that were counted twice. So I would have 12 plus 5 minus the 3 overlaps. Let's see here. Out of 30. So I'd end up with 14 out of 30. And so 14 out of 30 would simplify into 7 out of 15. So I hope that makes a little bit more sense, that some things are not mutually exclusive, like being female or playing soccer. Now, if I go through here, and I'm going to erase what I've already done so that I can start over. Some things are mutually exclusive. And let me erase all of this. Okay. So certain things are going to be mutually exclusive. Because what if I want basketball or hockey? Now, can these individuals be doing basketball and hockey at the same time? No, because if you look through here, Stacy's doing basketball, Zano's doing hockey, Daryl's doing basketball, Becca's doing basketball, Tony's doing basketball, Michael's doing basketball, and Wayne is doing hockey. So notice that none of them are overlapping in this case. They're either doing basketball or they are doing hockey. So if I go through and count all the basketball, that's 1, 2, 3, 4, 5 basketball. And then if I count all the hockey, that's 1, 2. That gives me my total of 7 individuals out of my 30. Basketball or hockey, those things are mutually exclusive. In this particular instance, you cannot be doing 2 sports at the same time. So you have no overlap. Now let's go back to the car types. If you think about mutually exclusiveness here, that is if I wanted a Toyota or a Chevy. Notice that there's no intersection. Same thing would happen if I said I wanted an SUV or a truck. Those 2 rows would not intersect. Those things would be mutually exclusive. So you wouldn't have to worry about this part right here. So I want you to try some examples with the or, and then let me know if you have questions.